So, 3 lists of numbers up here on the board, and I asked you to kind of take a look at those and see if you can tell me something about those that might be what I'm talking about when I say each one of those is an arithmetic progression. And then we'll formalize the definition on the next slide. What are you seeing? What are you observing about these 3 lists that might be special characteristics of those things? Catalina, what are you thinking? Okay, so noticing for the first one, adding the same thing over and over. So adding how much over and over? Adding 10 over and over. Everybody good with that? Is that the same kind of thing you were seeing, Hope? What about the second one then? Adding 6 over and over to get that. And then you said adding or subtracting. So last one we're doing what? Subtracting, but I want to add all the time. So instead of subtracting 3, I could be adding -3 over and over. So you guys are exactly correct. What makes these things arithmetic progressions is I'm going to pick a first term, and then I'm going to add the same thing over and over. If I add a positive, I get numbers that get bigger and bigger. Those lists, those sequences are increasing. If I add a negative, and my numbers get smaller and smaller, so this last one is decreasing. So far, so good. Okay, another thing up here that was the same about all of these all 3 happen to have ... dots at the end of them, meaning keep going forever and ever and never stop. I don't have to have that for it to be an arithmetic progression. I could have said this one stops at 12. It's still an arithmetic progression. It's just one that ends, whereas the first 2 don't. Also notice there are no ellipses, no ... dots on the left end. I must have a starting number. I must say what's first in the list and then start adding after that. It is not like what you did in Algebra 1 when you did the set notation for all of the integers. And so you had ... -3, -2, -1, 0, 1, 2, 3, ... That went both ways. Integers are not an arithmetic progression because they don't have a first one. Positive integers, we could say that that's a progression because it starts with 1 and then only keeps going forever in the positive direction. So far, so good with all that? So let's formalize some of these definitions and get these written down in your notes. A sequence is just some arrangement of numbers with or without a pattern in a definite order. That means we have a first term and we call it A1. We have a second term in the list and we call it A sub 2. And then we have a third term, A sub 3, and a fourth term, A sub 4. And we can keep going or we can stop at some point. But those subscripts just say the first in the list, the second in the list, the third in the list. The order matters so that we can be adding the same thing. We can't just jumble the order, then we would not be adding the same thing over and over. As I was mentioning before, it can stop or it can keep going forever. Finite if it comes to an end. Infinite if it has the 3 dots and keeps going forever and ever. Progression means there is a particular kind of pattern to these. You're going to take a term and do something to it to get the next term. Whatever you did, you're going to do the same thing to the next term to get the one after that. And you're going to follow that same pattern forever and ever. Today we're going to be talking about take one and add the same thing over and over. Later on, we're going to talk about some other kinds of patterns in a future lesson. Besides adding a positive or a negative number over and over, what's your guess of something else we might do to get a different kind of progression if we didn't want to add? Evan? No, what were you thinking? We're not going to try to get into imaginaries. It's going to get a little bit crazy on us, but good idea. Hope. We can multiply by different things to get the terms after that. And those will be called geometric progressions, and we'll get to those a little bit later. There also are progressions where you multiply by this, and then you add something else. They don't have a special name, but they'd be progressions because they follow a pattern. The ones that we are talking about today are arithmetic progressions or arithmetic sequence, either term. Arithmetic means it's progression. It follows this pattern of adding the same thing over and over and over again. That number that we add over and over again, we are going to call D. It is the common difference. So as we observed in the examples I had on that first slide, if we add a positive, then our progression is going to be increasing. If we add a negative, we'll get a decreasing progression. If I want to know what D is, and I know the first and second terms, the first term plus D is the second one, so the second term minus the first is D. The 100th term minus the 99th term will tell me how much I added, so that will tell me the D. I can take any two terms. I can take the one that's farther out in the list minus the one right before it, and that'll tell me how much I added each time. So depending on what we're given in the problem, we can be subtracting a 100 minus a 99, or a 1001 minus a 1000 if we need to figure out what D is. The other new thing that we're going to talk about today will be arithmetic means. And first off, it only makes sense to talk about arithmetic means if we're talking about a finite sequence. If we only have a first and a last and one thing in between, the arithmetic mean is what we're used to thinking of as the mean or the average of the first and the last terms. But we can have a first and a last, and we can put 5 things in between, and all 5 of those extra ones are called arithmetic means. We don't have to do it with just one. And we'll have an example where we work through how that would work. Looks like we've just about finished getting this copied down. Next thing that we're going to do is to try to come up with a formula, because it's going to be a total pain if I tell you the first term is 3, and I tell you the common difference is 7, and then I ask you for the 115th term. And I really don't think we want to do plus 7, plus 7, plus 7, and then count. Do we have 115 of them yet? That's going to take forever. So let's see if we can come up with a formula to make life a little bit easier for us. So our first term we know is going to be A1. Our second term is going to be that first term plus D. That's just what we've said for our definition, right? Then to get our third term, we're going to take this second term and add D again. So my third term is going to be my second term plus D. But my second term was A1 plus D plus another D. Now I have A1 plus 2D for my third term. If I want my fourth term, it's going to be the third term plus D again, right? But my third term is A1 plus 2D plus another D, means I have A1 plus 3D. So I'm hoping you can help me figure out a pattern. A2 is A1 plus 1D. A3 is A1 plus 2D. A4 is A1 plus 3D. A5 is A1 plus 4D. A11 is A1 plus 10D. I should see some hands going up. What is the relationship in there? Elizabeth? Plus 1 less than the term number. So the way that we can write that, mathematically speaking, is the nth term an is the first term plus 1 less than the term number times d. And that will make our lives much easier for some of the homework problems that we will be working. And hopefully you guys leave here this period. I had a student at the end of last period saying, I really like this. This totally made sense. Every bit of it I followed along with. So hopefully we'll get you guys to the same place as we work through these examples. Just a couple of you still getting that written down. So If I need so when I use the formula, you're going to be saying things like A11 is A1 plus 10D. A52 is A1 plus 51D. And you'll be writing that down a lot as you work your way through different problems, depending on which term number you are talking about. This first example is so easy, you're going to wish they were all like this, but you know Saxon, they give you a few easy ones, but then they want to challenge you and push you just a little bit more. So first one, super, super easy. Write the first 4 terms of an arithmetic sequence. The first, okay, that's one of the ones I have to write down. I have to write down the first 4, so the first one is 3. I need to write down 4. I know the common difference is -5. So Holly, what's my next term going to be? I'm going to add a -5, so I get -2. Mia, what's the next term? And everybody, what's the last term? See what I mean about wishing they would all be that easy. You'll get a few, so you'll get a break once in a while on a problem like that. Okay, this one is not bad, just one step more difficult. Find the 16th term of an arithmetic sequence. The first term is 24. And the common difference is 13. Do not, please do not attempt it like this. The first term is 24, add 13. The second term is 37, add 13, and what do I get? 50, add 13, and I've got 63, so that's 4. Keep going, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th. Please do not do it that way. Too many places to make a mistake in the addition, and it takes too long. Instead, let's use the handy-dandy formula that we just figured out and you just wrote down. So I want the 16th term, and I'm going to warn you, read these carefully. 16th is not 60th. I have students that mix up 16 60th, 13 30th. Read carefully. That's the most common mistake I see on these problems each year. So 16th term. So Callum, what is my formula for the 16th term? The 16th term is what? So what's n minus 1 going to be here? So all I have to do, I don't have to do the 16 minus 1, just the A1 plus 15D. Do I know A1? Do I know D? Okay, with or without calculator help? Figure that out for me. If it's on homework, you may use a calculator. If it's on the calculator part of a test, you may use the calculator. If it's on a no calculator part of a test, you would survive 15 times 13, long multiplication, figuring out what that equals, and then adding 24. So Sydney, you have a final answer? Anybody else 219? And I'm going to label that that is my 16th term. So what do you think? Was that a pretty easy one also? Not quite as nice as the first one, but still very easy and very doable. Okay, let's try this new thing now with arithmetic means. So this says put 3 arithmetic means between 2 and -4. So I'm going to have 2 and I'm going to have -4, and I need to figure out 3 numbers to put in between there so that they are all evenly spaced with this arithmetic progression kind of a pattern. So I need to figure out a formula for -4, and there are 2 ways that you can get there, and they're pretty much equally easy. I could say that this one is A1, so this one is A1 plus D, so this one is A1 plus another D, and this one is A1 plus yet another D. Oh, so this one is A1 plus 4D, so I can work with -4 is A1 plus 4D. The other way you could get to that, also equally good, you could say this is A1, A2, A3, A4, A5, and then my formula A5 is first term plus 5 minus 1 or 4 times d. So either way, I get to this formula. So far, so good with that. Okay, do we know anything we can plug into that? Do we know A1 or do we know D? Seeing a couple of heads nod. Gavin, what do we know? So let's plug 2 in right here. And you guys figure out for me what that means D has to be. Relatively easy algebra problem. Billy, what are we going to do here to get that? Giving me, so D is going to be, okay, and so you may use either -3/2 or -1.5 or -1.5, depending on whether you like fractions or decimals better. That's going to be our common difference. That tells us that if we know the first term, it's that -1.5 that we need to be adding each time. So I don't care fractions or decimals. 2 plus -1.5 or 2 plus -1.5. Giselle, what does that give me for my next one? That's going to give me +0.5, or if I like decimals, 0.5. Just do it the same all the way across. All decimals are all fractions. Let's add -1.5 again. Ryan, what will that give me for the second term? -1 either way. Add -1.5 again. Morgan, what do we have? So -5/2 or -2.5 or -2.5, depending on which one of those you preferred. The first and the last are not means. The means are the ones in between. So to mark our final answer here, we would either put a box around those 3 decimals or these 3 that are in fraction form, and those would be our arithmetic means. So that's not bad either, right? Just need to know what the vocabulary means and set it up and work through it. Okay, example 4 here is my favorite one of this group. We want to write the first 5 terms. Oh, maybe this is like example 1. I'm just going to write down my first one, add. Oh, not so lucky. They don't tell me the first one. So I'm going to write down what they do tell me and see if I can come up with any good ideas of what I need to do. They tell me the 21st term is -60, and the 50th, not 15th, term is -176. Okay, I need something more than that to go on. Do I have any formulas for the 21st and 50th terms? Does our formula work for 21st term? Does it work for 50th term? So we're going to write down what those would be. So Hope, what's my formula for the 21st term? So A1 plus 20D for the 21st term. Maya, what would my formula be for the 50th term? No, the 50th term plus 49D. We look at the term number to figure that out. So the 50th term is the first one plus 49D. Everybody good with that? So as I look at that, I see 2 equations. Do those equations have the same 2 variables? System of 2 equations, 2 unknowns. We can solve it. These are nice because we can easily get the A's so that they cancel out. All we have to do is to pick one of those, and I'll pick this one, second one, and multiply everything by -1. So that's a plus, that's a minus, that's a minus. So let's see, 176 minus 60, what's that going to give me? 116, did I do that right? And the A's go away, and -29D. Check my arithmetic there. So let's see, I know D's going to be negative something. Help me out. I don't know if that's going to come out evenly or if that's going to be a messy fraction. What are we coming out with? Who's got that? Anybody have that for me yet? What, Evan? So negative, okay, that's not bad. So -4. Okay, so now I know D. What am I supposed to do this? I'm supposed to get the first 5 terms. How am I going to know where to start? How do I come up with A1? I got to start writing down my list. How am I going to get there? Should see more hands going up. How do I get there? Benjamin, what do I need to do? So plug it into one of those 2 equations and solve for A1. Do you like the 60 and 21 or the 176 and 49 one better? Thank you so much. I really didn't want to have to deal with multiplying 49 and all of that good stuff. So I'm going to take this. I'm going to take this. And -60 is A1 plus 20D, and D is now -4. So that's a -80. And if I add 80 to both sides, A1 is 20. So to write the first 5 terms, the first one is 20. D is -4. Tessa, what's next? Everybody, what's next? And then. Do I have 5 of them yet? So that is all that I needed to do. Are we good with that one? Okay, just one more. And the only difference with this last example is sometimes you can have an arithmetic sequence that's not just numbers. You may have some variables in there, but it still follows the pattern of adding something with variables, adding the same something with variables, adding the same something with variables as we go from term to term to term. So we're going to start off writing down things that we know in this one. We want to find the 10th term. So we want the 10th term. And what's my formula for the 10th term? Sydney, what will my formula for the 10th term be? And let's see, what else do I know? Oh, good. I know that the first term is 3x plus 2y. So that means I've got 3x plus 2y right there for the first term. So the 10th term is that plus 9d. If I just knew d. Well, let's see. What information haven't I used yet? I have not yet used that the 6th term is 8x plus 12y. What else do I know about the 6th term? Ian, what would my formula for the 6th term say? So if these are both A6, these two have to be equal to each other. So 8x plus 12y needs to be A1, but A1 is 3x plus 2y, and then I've got my plus 5d. Can I solve that for d? So Gina, help me out. What do I need to do? What does that give me? So if I subtract 3x on both sides, I've got 5x, and then subtract the 2y, so I have plus 10y, and that's 5d. Allie, help me out. I want d. I have 5d, so what do I need to do? So divide everything by 5, which means d is how much? So x plus 2y, everybody good with that? So then I can take that and plug that in over here. So I have A10 is now my 3x plus 2y plus 9, and d is x plus 2y. So if I distribute all of that, 3x plus 2y plus 9x plus 18y. Combine like terms. Shane, help me finish up here. And there is my 10th term. It just happens to have x and y in it. So thumbs up, thumbs down. Are we understanding everything? In good shape with this lesson? It's all making sense? Or thumbs down, we've got some questions. We aren't quite sure. All right, looks like we are in good shape, which always makes me very happy.